Hello and welcome to the Titus Timeout podcast. I'm Jenny Abney-Civy, and today I'm going to talk about electric reheat. Every now and then we get a VAV box schedule with electric heaters selected with really high temperature rise. So today I wanted to cover the electric heater calculations and make some recommendations. The equation that relates kW, CFM, and temp rise is pretty simple. It's kW equals CFM times temperature rise divided by 3160. So let's look at an example. Ideally, per ASHRAE, you don't want your heating supply temperature that's coming out of your diffuser to be greater than 15 degrees over room temperature. So for a 75-degree room, you want about 90-degree air coming out of the diffusers and heatings. I'll talk about this a little more in a minute, but let's calculate the kW first. And make a little bit of room. Okay, so let's assume we have 300 CFM in heating in a single duct box and that the supply air temperature into the box is 55 degrees. So that would look like this. The kW equals 300 CFM times our 35 degree temp rise, which is 90 degree out of the box minus 55, divided by 3160. And that equals about 3.3 kW. Let's call that 3.5 kW. And that will give you 91 degree discharge temperature actually. Let's move this up a little bit. Okay, so per UL, we have to have thermal cutouts and an airflow proving switch in boxes with electric heat. If you exceed 125 degrees, the thermal cutout will switch the heater off. If you don't have enough airflow, you can't turn the heater on. You'll also get hotspots in the electric heater elements, which will trip the thermal cutouts. So we recommend that you have at least 80 CFM per kW. So in our example above, that would be 80 CFM times 3.5 kW, which would mean that you'd want a minimum of at least 280 CFM for proper heating operation. So now let's get back to what I said about ASHRAE recommending that the temperature differential between the room and the heating supply air not exceed 15 degrees. So let's draw the perimeter here, and we'll put a slot diffuser up here in the ceiling. When heating from overhead, you have to push the ventilation air into the room with enough energy to get it from the ceiling diffuser to the occupied space, specifically within 4.5 feet of the floor. The warmer the air, the shorter the throw will be. In fact, ASHRAE 62.1 says that if you use air warmer than 15 degrees above the room temperature, you have to bring in 25% more ventilation air. If you have more supply air, you'll have to have a higher kW to maintain that same warmer temperature. Let's make a little room over here. So let's say for some reason you want 105 degree air. So you have to bring in 25% more air, that equals 375 CFM now. So the kW equals 375 times 50 because your differential is higher, divided by 3160, and that equals about 6 kW. So now not only do you have to pay for more supply air, you also have to pay for a bigger heater. And it's very possible that you won't be able to get this warmer air into the occupied space and your occupants will be uncomfortable. All of this will also raise your energy cost. So there are some electric heater rules and recommendations. Don't forget to subscribe to our YouTube channel, and thanks for taking a time out with us.